talk about these problems on the board.
All
to show
right,
work that you
ready,
guys do.
set, go.
Okay, so when we look at Shukai's problem number 1, tell me how he got negative 5/4 for the y value of the min, Michael.
Just by plugging in 1/2 to the original equation.
Excellent. Tell me about the brackets on his increasing and decreasing interval, Spencer.
So it has to include the 1/2 because in that interval from 1/2 to infinity it is increasing, and then it also includes the 1/2 when it's decreasing too. It's the same thing.
Excellent. So we have the overlap there. And then if we wanted to extend this, so problem 1 didn't ask us to, but what would you say about the concavity of the function, Shukai?
The concavity will be 2. You take the derivative of the derivative. So
Okay. Good. You take the derivative of the derivative. So does that, from looking at the graph, is it concave up or concave down?
From the graph, when it's less than 1/2 is concave down.
Help him out, Spencer.
It's concave up.
How do you know?
Like the whole ladder, like it's. I don't know how to explain.
Right. So this is hard for Shukai because he's in English is not his first language. But remember, concave up. It's
So-
concave cup. So it makes a cup like you hold water in. Right. So this, even if you look at it, and I think that Shukai is right to look at it side by side because that's what we'll do. But this graph is also concave up.
Oh, so whenever it's pointing up, it
Not
will.
whenever it's pointing up, because you could have this, and that would be concave down. It's the shape of the roundedness.
Oh, okay.
Okay, so the roundedness is pointing up like it's a cup, because that would be pointing up, but this would be concave down. Okay?
Oh, I got it. Yep.
So it's the direction of the roundedness that
Okay.
makes it concave up. All right. Very nice. Any complaints about Shukai's problem? All right. Love for Shuhai. Give him some magical spirit fingers. Excellent. Okay, number 3
Moving
for
to
Michael.
3.
Tell me about how did he know that the interval from -1 to 0 was increasing? Shukai? Oh, this is yours, not mine.
Yeah.
How did you know that the interval from -1 to 0 was increasing?
You plug the points. You plug a point in to the original equation between -1 and 0.
Not quite. Try again. Not the original equation.
Oh, the derivative of the original equation.
Correct. For the sign analysis, we're
Yep.
plugging the point into whatever we're using. So in this case, if we're looking at the first derivative for increasing and decreasing, we're plugging it into the derivative. The minimum or maximum gets plugged into the original function. All right?
Oh.
Any disagreements or complaints about Michael's work? Based on the graph, for what interval would this function be concave down, Michael?
From -1 to 1.
Great. And then how would you prove that algebraically, Spencer? How would you prove that the concave down interval is from -1 to +1?
Find the derivative. Find the second derivative, and then.
I'm not sure it's entirely from -1 to 1, Michael.
I think it's just from -1 to 0.
Right? It looks to me more like it's probably that there's an inflection point here and here, right? So this is concave up, and then this is concave down, and then this is concave up.
Oh.
So how would we test that, Spencer?
So you find the second derivative, and then with that you do a sign analysis on it too.
Great, great. All right, spirit fingers to Michael for excellent work. Shukai, don't get lazy. Just because you're filming the video doesn't mean you can skimp out on the spirit fingers. Okay, great. All right, let's look at number 5. Spencer tackled one that required a lot of methodicalness. Make sure you don't forget your hanging parentheses there, Spencer.
Oh.
Okay, so he had to use the product rule Yes, and use substitution at the same time. So this is when you, so talk to us, how did you get here from here, Spencer?
I put it under a common denominator and then cancel things out.
Okay, so
That's what I did too.
Yes, if you get that.
you put it under the common denominator.
Yeah, so just
I think you missed something from that step. You shouldn't have a 2 on the denominator. That 2 cancels out with 1/2 cancels out with -2. So you should just have square root of 8 minus x squared.
Right, okay, yeah.
Come fix it. Nice catch, Shukai. Good job figuring that out.
Thank you. Yep.
Okay.
There we go.
So then the common denominator was the square root of 8 minus
X squared.
x squared.
Yeah.
So, okay, and then you combined because
It's
then
the
you
negative x minus negative x because the radical in the numerator goes away because it's multiplied by the top and bottom. So then it's like
Yep.
it's
Okay.
8 minus x
So
squared
this
minus x squared over
negative x squared gets combined with this once
Yep.
the
Yeah, that's
square
what-
root is
yeah.
multiplied. Okay. We can agree with that. So did our adjustment of the 2 here change the point at which it was undefined, Spencer?
No, I just
Why not?
Oh well, I just copied my work wrong on the 2 part.
Well, but tell us, so if someone did this wrong, would that change the
Oh
point at which
no,
it was
because you
undefined?
just need the numerator.
No, not to determine where it's undefined.
It's
Well,
constant.
it's still 0 at that point. 'Cause
Why?
Under the radical is 0.
Thank you. So the 2 does not impact what's under the radical. So even though we're taking this away, because it was just a miscopy of the work, it doesn't change the fact that this is correct, that it's still undefined at plus or minus square root of 8. Okay. So given that it is plus or minus, that is undefined at plus or minus square root of 8, because the derivative is undefined there, what does that mean for Spencer's increasing and decreasing intervals? Let's look at the graph. So let's look at the,
So it doesn't go to infinity.
Yeah, it doesn't have infinity.
Okay.
so what, Spencer?
So then it's like finite. So it doesn't go to infinity.
It's finite. So do you want to go up there and try to
Yeah.
fix those intervals?
Would it be like that?
Yes. So, well, yes, because it's undefined at that point. But I want to be clear, the reason why it's undefined here, I think maybe I misspoke slightly in a way that matters. It's not because it's undefined here, it's because it's undefined here.
Okay.
For the original function, the range is from negative square root of 8 to square root of 8. So because the range is from negative square root of 8, everything that follows, the concavity, the increasing and decreasing, is still bounded by that same range. So we have to include it when we're talking about intervals of increasing, decreasing. So we're a little sloppy over here because we had infinite polynomial functions and not defining the range, but I think it would be important for both of these to say that the range is all real numbers. Because when we get here, it was important to notice that the range was bounded because that impacts every interval that comes after. Everybody good with that?
Yep.
Let's give Spencer double spirit fingers for tackling one of the extra hard ones on the board for us. Double spirit fingers.